Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we're drifting gently into the mysterious journey of thunder, how it rumbles across distant hills, echoes through sleeping cities, and rolls like a whisper from clouds you cannot see to ears that are ready for rest. There's a quiet kind of wonder in it, the way sound travels so far, so deep, so wide, reminding us that the sky is never silent, even in the hush of night. Maybe your day has been full of light, of movement, of thoughts that won't quite settle. Or maybe you've been floating through the hours already half asleep, looking for just the right voice to carry you the rest of the way. Either way, I'm glad you're here. How's the sky looking where you are? Maybe cloudy, maybe clear, or painted with stars you haven't yet noticed. If you enjoy these gentle journeys through weather and wonder, feel free to like or subscribe. It helps more sleepy minds find their way here, one peaceful moment at a time. For now, snuggle in, let your breath soften. There's nothing you need to do but rest. Let's begin. Hello again, friend. Tonight, we're listening closely to something bold but softened by distance, something that rolls across the sky like a sigh from the heavens themselves. Tonight, we're listening to thunder, the sound of lightning's breath. You've likely heard it many times. A distant rumble, a sudden crack, or a low, soft growl echoing across open fields. But what exactly is thunder? To understand it, we begin with a flash of lightning. Though brief, often no longer than a second or two, lightning is immensely powerful. It heats the air around it in an instant, to temperatures hotter than the surface of the sun, up to 30,000 degrees Celsius in a heartbeat. This heat causes the surrounding air to expand explosively. Imagine standing beside a quiet balloon, and then someone fills it suddenly with fire-hot air. The air would push outward with force, breaking through the calm like a wave through still water. That is thunder. It isn't the lightning you're hearing, not directly. It's the air around it, reacting, surprised, stirred, startled into motion. Thunder is the sound of that expansion, the sky's voice in response to the strike. And just like a voice, it changes depending on where and how it speaks. A bolt of lightning close to you might sound sharp, a crack or a snap. But farther away, thunder slows down, its edges softened by the journey. It rolls across hills, bounces off buildings, echoes through valleys and trees, and it takes its time. That's because sound, unlike light, travels slowly. Light reaches your eyes almost instantly, but thunder takes its time to arrive, roughly 1 mile every 5 seconds, or about 343 meters each second through air. That's why you can count the seconds between the flash and the rumble, a gentle little rhythm. 1 1,000. 2 1,000. Each second tells you how far away the storm is sleeping. Thunder doesn't come from just one spot. Lightning bolts often stretch across the sky, sometimes for miles. Each part of the bolt causes air to expand and collapse, forming many small bursts of sound. These blend together as they travel, creating the rolling, rippling effect we hear as thunder. And sometimes, the air's temperature and structure can bend the sound, causing it to fade, or grow louder, or seem to echo long after the storm has passed. On warm summer nights, thunder may feel like it's breathing all around you, as though the sky itself is exhaling, soft, slow, powerful. Not a warning, not a threat, just the sky expressing itself, telling you a story from somewhere far away. The next time you hear it, try to listen with new ears. It's not just noise, it's the voice of the lightning, the breath of heat meeting air, and air answering back with a rumble that rolls gently into your world. So now, let's close our eyes and imagine the clouds above us glowing softly with distant light, a flicker far away, followed in time by a calm and curious sound. Thunder, the breath of a flash. Let it soothe you now. As we drift quietly into Chapter 2. Welcome back, dear listener. Tonight, we settle into the moment just before sound begins, a space between thoughts, a stillness so quiet you can almost hear it, before thunder rolls, before wind rustles the leaves, before raindrops tap gently at your window. There is silence, and in that silence, sound is waiting. All sound, whether a whisper or a roar, begins as a wave. Not a wave you can see like ocean tides, but a wave made of pressure, moving through air. Imagine the air around you as soft and invisible fabric. Touch it in one place, and that movement ripples outward. When lightning strikes, or when anything moves forcefully enough, that energy presses into the air, and the air, like a pond touched by a stone, carries the ripple forward. These ripples are called sound waves. They travel through the air in every direction, pushing and pulling the molecules around them ever so slightly. Not enough for you to feel, but just enough for your ears to notice. And it all begins with a vibration, a bird flapping its wings, a breeze brushing across your window pane, or a sudden spark of lightning flashing in a summer sky. Each of these creates movement, and that movement disturbs the calm air, sending out pressure waves like gentle rings in still water. Close your eyes now and picture those waves, radiating softly, outward and outward. Slower than light, but steady, persistent, a whisper carried on a breeze. At the heart of every thunderclap, every gentle rainfall, every faraway train, is this quiet beginning, a single push, a moment of motion that becomes sound. What's truly lovely is that sound, once born, doesn't simply vanish. It travels, through air, through walls, through time. Sometimes it meets something, like a tree or a hill, and bounces back. That's an echo, a sound wave returning home. Other times, it diffuses slowly, like steam rising into the evening air, becoming part of the hush again. Some sound waves are strong and sharp. Others are so gentle we barely notice them, like the soft hum of night insects or the distant hush of wind over grass. All begin the same way, from silence into movement, into music. So tonight, if you find yourself listening to the quiet between thoughts, to the air in your room, to the gentle breath of your own body, remember, even silence holds the promise of sound, a peaceful potential, waiting patiently. No need to fill it, no need to chase it. Just rest there, in that softness. Let the waves of sound, real or imagined, roll gently around you, cradling you in calm. And as we float further into this quiet journey, let's drift onward. To Chapter 3. Welcome back, dear friend. Tonight, we follow a sound, not from its birth, but through its journey, a quiet ripple through the sky, a breath stretched into motion. We're tracing the speed of sound itself, not lightning fast like a flash, but swift enough to carry thunder to your ears within seconds. Sound moves through air at around 343 meters per second. That's about 1,235 kilometers per hour, or roughly 767 miles per hour. But in the sleepy stillness of night, it doesn't feel that fast, does it? It feels like a slow, rolling wave, gentle and unhurried. And that's part of the beauty of it. Though sound travels quickly, it does so invisibly, unfolding softly through the sky. Now, while 343 meters per second is the typical speed of sound, it's not a fixed number. It changes ever so slightly, depending on a few things, like the temperature, the humidity, and even the altitude of the air it's moving through. Let's start with temperature. When the air is warmer, its molecules move faster. They're already in motion, already buzzing with energy. So, when a sound wave comes along, they're more ready to pass it along, like a message in motion. That means sound moves faster in warm air, and a little more slowly when the air is cold and still. Imagine a hot summer evening, cicadas humming, the last light fading. In that warmth, a distant thunderclap may reach you just a bit quicker, its voice carried easily across the balmy sky. Now, what about humidity? You might think that dry air would be better for sound, but surprisingly, it's the opposite. When air is humid, it holds more water vapor. Water molecules are lighter than the nitrogen and oxygen they replace. So, humid air is less dense, and in that lighter air, sound travels just a little faster. A moist, misty night might carry sound more smoothly than a dry desert evening. It's subtle, but it's real, part of the quiet physics of the atmosphere. And then, altitude. The higher you go, the thinner and colder the air becomes. Sound moves more slowly through this thinner air. That's why, in the mountaintops or high-altitude plains, everything might feel a little quieter. The world's slightly more hushed, but still, sound travels. Up mountains, over lakes, through forests and cities. It weaves through tree branches, around corners, across water. It's shaped by the space it moves through, but it always finds its way. Now, as you lie here, picture it. A single sound, maybe a clap of thunder, begins far away. The sky is calm, and then a wave begins its journey, moving through warm air, over fields, through trees. It touches nothing, and yet moves through everything, inaudible at first, then growing clearer, fuller, rounder. It reaches your window, your walls, your ears, and then it's gone again, folded back into silence. The speed of sound is swift, but it's not a race. It's a story told gently through air. Every second, every meter, a quiet passage through the atmosphere. Let your thoughts move just as softly now. There's nowhere to go, nowhere to be but here, listening to the sky. And as we rest inside that slowness, we drift gently into Chapter 4. Hello again, sleepy soul. You may have noticed, on quiet summer nights, you see the lightning long before you hear the thunder, a bright flicker across the sky, and then silence, and then a soft rumble rolling in. Why is that? Tonight, we explore that peaceful little pause, the gentle delay between lightning and thunder. It begins with light. Light travels unimaginably fast, about 300,000 kilometers per second. That's so fast, it reaches your eyes almost instantly, no matter how far the source. So, when a bolt of lightning strikes, you see it right away. A flash that carves across the clouds or dances from cloud to ground. But thunder, as we've just learned, travels much more slowly. At about 343 meters per second, sound takes its time. And that's why, even though lightning and thunder are born in the same moment, you experience them separately. It's a little like watching fireworks. First the light, then, a heartbeat later, the sound. That delay tells a story. In fact, it's something you can measure. A little bedtime math, if you like. For every 5 seconds between lightning and thunder, the storm is about 1 mile, or 1.6 kilometers, away. You can count it like this. 1 1,000, 2 1,000. Each second is a step through space, a flash. 1 1,000, 2 1,000, 3 1,000. And then the thunder comes. That storm is about 3 miles away. Simple, quiet science, right there in your ears. It doesn't just tell you distance, it invites you to listen, to become part of the rhythm of the storm. And what a rhythm it is. Lightning reaches out like a quicksilver vine, while thunder follows behind, slower, deeper, softer. 2 expressions of the same event, separated by nature's own timing. On especially distant nights, you might see the flash, but never hear the thunder at all. It simply fades before it reaches you. Not all sound makes the full journey. Some is softened by terrain, absorbed by forest, bent by winds. The sky decides what you hear and when. So next time the sky lights up, pause, breathe, count softly if you'd like. Let the silence between the flash and the rumble hold you. It's not emptiness. It's a message in motion. Time and sound wrapped together in a nighttime lullaby. And if you happen to fall asleep before the thunder arrives, that's perfectly fine. The sky will finish telling its story, even if you're dreaming by the time it does. Rest easy now as the storm drifts farther, and we float onward into Chapter 5. Welcome back, dear friend. Tonight, we listen more closely to the character of thunder, not just its presence, but its personality. Sometimes, thunder arrives as a sudden, sharp crack, quick and startling in its clarity. Other times, it rolls slowly across the sky, a low and steady rumble that seems to wander through the clouds before gently fading away. Both sounds come from the same beginning, lightning heating the air in an instant. And yet, what we hear can feel entirely different. The difference often depends on distance. When lightning strikes close to where you are, the thunder can sound crisp and immediate. A short, defined clap. That sharpness happens because the sound waves reach you before they have much time to spread out or soften. They travel a shorter path, remaining tightly packed, like footsteps echoing in a nearby hallway. But when lightning flashes far away, the sound must travel much farther to reach you. As it journeys across open fields, over rooftops, through trees and shifting air, the waves begin to stretch and scatter. Different parts of the lightning bolt create sound at slightly different moments and locations along its path. By the time all of those tiny bursts of sound arrive at your ears, they blend together. The result is a rumble, a layered, rolling sound that feels less like a crack and more like distant drums across the hills. Landscape also shapes what you hear. Hills can reflect sound, sending small echoes back into the air. Buildings can bounce and scatter it. Forests can soften it, absorbing some of the higher, sharper tones and leaving behind deeper notes. Even the structure of the lightning itself matters. Some lightning bolts branch and twist through the sky, creating a long, zigzagging channel. Each section produces its own little expansion of air. When those expansions reach you at slightly different times, they create that rolling, rippling texture. It's a bit like listening to a long train passing in the distance. You don't hear a single sound. You hear many small sounds overlapping, weaving together into one continuous murmur. Close thunder feels sharp because you are hearing the wave almost all at once. Distant thunder feels low and rolling because you are hearing it in layers. There's no need to label one as louder or softer, better or worse. They are simply different expressions of the same sky. Imagine now that you're resting by a window. A storm is somewhere beyond the horizon. You see a flicker of light, and then a slow, velvety rumble drifts in, as if the clouds themselves are turning over in their sleep. Or perhaps the storm is closer. A bright flash, and a quick, clean crack follows. The air settles again just as quickly. Both are natural. Both are simply the sound of air responding to energy. And as you lie here, safe and calm, you can let those sounds become part of the atmosphere of your thoughts. Sharp or soft, near or far, each one eventually dissolves back into quiet, just like everything does. Now, let's follow that sound a little farther, into the very air that carries it, and drift gently into Chapter 6. Hello again. Tonight, we imagine the atmosphere not just as open sky, but as a gentle pathway, a channel through which sound can travel, curving, bending, and gliding across distance. The air around Earth is not the same everywhere. It exists in layers, each with its own temperature and density. Though invisible, these layers quietly shape the way sound moves. When thunder rolls outward from a lightning bolt, it doesn't always travel in a perfectly straight line. Instead, it can bend. This bending is called refraction. It happens because sound travels at slightly different speeds in air of different temperatures. As we learned earlier, warmer air allows sound to move a little faster than cooler air. So, when sound waves move between layers of air with different temperatures, their speed changes slightly. And when speed changes, direction can shift as well. Imagine a whisper moving through a long hallway. If the hallway curves gently, the whisper follows the curve. In much the same way, sound waves can curve through the sky, guided by the structure of the air. On clear nights, especially after sunset, something gentle often happens. The ground cools faster than the air above it. This creates a layer of cooler air near the surface, with warmer air resting above. In this situation, sound waves from distant thunder can bend downward toward the ground. That means you might hear thunder from a storm that is farther away than you would expect. The atmosphere has quietly carried it to you. Other times, sound may bend upward, lifting away from the surface and fading before it reaches certain places. The sky chooses its pathways softly. Wind can also guide sound. If the wind blows from the storm toward you, it can help carry the sound along. If it blows the other way, it can gently slow the sound's arrival or soften it. Think of the atmosphere as a vast, invisible tunnel system, not rigid like stone, but fluid and ever-changing. Within it, sound drifts like mist through valleys, sometimes clear, sometimes distant and muted. That's why thunder can seem louder at night. The cooler air near the ground and the stillness of evening often help sound travel more smoothly, with fewer disturbances. As you rest now, imagine the layers above you, warm air resting atop cooler currents, soft winds weaving through them, invisible pathways stretching across the sky. Somewhere far away, lightning flashes. Thunder begins its journey. The air receives it, guides it, bends it gently, and after traveling through miles of atmosphere, through curves and currents and quiet temperature shifts, it reaches you, not as a straight line, but as a story carried through layers of sky. The atmosphere is not empty space. It is alive with motion, with structure, with delicate channels that shape every sound you hear. And tonight, it carries only calm. Let your thoughts move just as freely, bending softly, carried by gentle currents of imagination. The sky is vast, but it is also kind, and we will continue drifting through it in the next chapter. Welcome back, dear listener. Tonight, we rise gently into a quiet arrangement of air, a subtle layering that changes how the sky carries its voice. Most days, the air near Earth's surface is warmer than the air above it. Warm air rises, cool air settles, and the atmosphere moves in a soft, steady exchange. But sometimes, especially in the evening, the pattern turns upside down. The ground cools quickly after sunset, releasing the warmth it gathered during the day. The air just above it cools too. Meanwhile, a layer of warmer air lingers higher up, like a soft blanket resting above a chilled field. This is called a temperature inversion. Instead of warm air rising, cooler air now rests below warmer air. And this gentle reversal creates something remarkable for sound. When thunder rolls outward during an inversion, the sound waves move upward at first. But as they enter the warmer layer above, they begin to bend. Because sound travels faster in warmer air, the portion of the wave that enters the warmer layer speeds up slightly. This difference in speed causes the wave to curve, and instead of continuing upward, it bends back down toward the ground. The sound becomes gently trapped between layers, not trapped in a harsh way, but guided, cradled, allowed to travel farther along the surface than it otherwise might. On such nights, thunder from a distant storm may reach you more clearly. It may seem to linger in the air, rolling softly across open land long after the lightning has faded from sight. The inversion acts almost like a ceiling, reflecting the sound back downward. The sky becomes a quiet chamber, carrying the storm's low voice across miles. And then there are the echoes. When sound bends and travels along these layers, it can meet hills, buildings, cliffs, or even large cloud bases. It reflects gently, returning in softened fragments. Not sharp repeats, but layered murmurs. A rolling thunderclap might stretch longer than expected, its final notes arriving as faint, distant whispers of the original sound. Imagine lying beneath a wide countryside sky. The storm is far beyond the horizon. You see no lightning now, only darkness and stars. And yet, a low rumble drifts in. It travels across fields, guided by that inversion layer, bending downward, sliding along the land. It feels as though the earth itself is humming quietly. Temperature inversions are delicate arrangements. They form easily and dissolve just as quietly when winds shift or the sun rises again. But while they last, they reshape the sky's acoustics in beautiful ways. They remind us that the atmosphere is never static. It is layered and dynamic, rearranging itself hour by hour. And with each rearrangement, the pathways for sound gently change. Tonight, if you imagine thunder traveling farther than usual, lingering just a little longer in the air, you might picture that warmer layer resting above cooler ground, a soft lid on the night. Let the thought comfort you. The sky is layered like a quilt, and sometimes it holds sound close to the earth, letting it drift lazily across the dark. Now, as that lingering rumble fades into stillness, we turn gently toward another landscape, into the trees, and drift quietly into Chapter 8. Hello again, friend. Tonight, we follow thunder as it leaves the open sky and enters a forest. Imagine tall trees stretching upward, trunks steady and rooted, branches reaching out like patient arms, leaves layered upon leaves, forming a canopy that filters light and sound. When thunder travels across open plains, it moves with little interruption. But in a forest, the journey changes. Sound waves, remember, are gentle ripples in the air. As they pass through a forest, they encounter thousands upon thousands of surfaces: leaves, branches, bark, undergrowth. Each surface interacts with the wave in its own quiet way. Some of the sound reflects, some scatters in new directions, some is absorbed, transformed into tiny amounts of heat as it brushes against soft leaves and rough wood. The forest becomes a kind of natural sound diffuser. Higher pitched sounds, the sharper cracks of thunder, tend to be absorbed more easily by foliage. Leaves and needles soften these frequencies, diminishing their edges. Lower frequencies, the deep, rolling rumbles, travel more smoothly between trunks and through open spaces beneath the canopy. The result is something beautifully gentle. Thunder that might sound bold and expansive in open air becomes rounded and mellow inside the forest, like hands resting softly on a drum, dampening its vibration. If you have ever been sheltered beneath trees during a distant storm, you may have noticed this effect. The thunder feels closer to the earth, less sharp, more like a low murmur carried through wood and leaf. The forest does not silence the storm, it reshapes it. Even the spacing of trees matters. In dense forests with thick undergrowth, sound loses more energy as it weaves through obstacles. In more open woodlands, with tall trunks and clear ground beneath, the deeper tones can pass more freely. Moisture plays a role too. After rain, leaves are heavier and surfaces softer. Damp conditions can absorb a bit more sound, making thunder feel even more subdued. Now picture yourself there. You are standing, or perhaps resting, beneath tall pines. The air smells faintly of earth and resin. Far above, clouds drift. A distant lightning flash brightens the horizon. Moments later, thunder arrives. But it doesn't crack sharply overhead. It rolls gently through branches, filtered and softened. It moves around trunks, between leaves, settling into the forest floor. The trees hold it for a moment, then release it. The sound fades into rustling leaves and quiet wind. Forests have long been places of calm refuge, and even thunder, when passing through them, becomes part of that refuge. It is no longer a bold announcement from the sky. It is a low, steady presence, integrated into the natural rhythm of the woods. The science behind it is simple: reflection, absorption, scattering. But the feeling it creates is profound, a reminder that landscapes shape not only what we see, but what we hear. And as you rest tonight, imagine that forest around you, tall trees standing watch, thunder softened by leaves. The storm continues somewhere far away, but here, beneath the canopy, all is gentle, and we will keep drifting, deeper into the quiet music of the sky. Welcome back, friend. Tonight, we travel to high places where the air is thin and the earth rises up in folds and ridges, to places where silence is deep and sound is free to wander and return. We're visiting the mountains, and here thunder speaks differently. In wide open skies, thunder rolls in long, unbroken waves. But in mountainous terrain, between hills and cliffs and canyons, thunder becomes something else. It becomes an echo artist. When sound meets a solid surface, like a rock face or cliff wall, it doesn't always stop. Instead, it reflects, bouncing back like a stone skipping across a lake. If the surface is angled just right, the sound is sent onward to echo again and again. Thunder, born from a distant bolt of lightning, begins as a single voice. But when it reaches the mountains, it becomes a choir. A low boom might arrive first, bold and brief, then a pause, and then the sound returns, slightly softer. A second voice, then another and another, each reflection a little fainter, a little farther, as if the sky is repeating itself, slowly fading into a hush. This is why thunder in mountainous regions often seems to last longer. The original sound is broken into layers. The echoes dance from ridge to ridge, wall to wall, canyon to canyon. Imagine standing in a valley surrounded by granite cliffs. Lightning flashes behind a peak. The first thunderclap arrives as a powerful crack. But then, the sound begins to stretch, as if the sky is breathing out in waves. One echo returns from the west wall, then another from the eastern slope. Still another bounces through the canyon to the north. Each return is softer, more ghost-like, but still clearly part of the same voice. You may even hear flutter echoes, quick, repeated pulses, as thunder skips between closely spaced rock faces, like a voice in a narrow hallway. And because each echo takes time to travel, you hear them in a gentle sequence. One, then the next, then another. The result is an illusion of endless sound. And while the thunder may have lasted only a few seconds in open air, here it lingers, reflected, refracted, reshaped by stone and time. Even the shape of the land matters. A wide, curved basin might funnel sound inward, concentrating it, while jagged cliffs may scatter it in many directions, creating a diffuse, layered murmur. The terrain becomes part of the performance. Now, picture it clearly. You're sitting beside a quiet mountain lake. Clouds gather above the peaks. Lightning flickers behind a far ridge. And then, thunder, strong at first, then softened, then scattered like ripples across the water. It rolls across slopes, curls between cliffs, each echo chasing the last, like footsteps in mist. There's no fear here, only the atmosphere performing one of its most haunting lullabies. In the mountains, even silence echoes, and thunder finds a place to echo too, carried, returned, remembered. So let your thoughts follow those echoes now. Let them bounce gently in your mind's quiet valleys. No need to hold them, just let them return, then fade again into stillness. And now, from high places, we turn toward the open plains. Let's drift softly into Chapter 10. Hello again, friend. Tonight, we find ourselves beneath a sky with no ceiling, a vast stretch of land, unbroken by mountain or forest, just space and sky. These are the open plains, where the earth breathes deeply, and sound is free to wander without end. Here, thunderstorms often seem louder, larger, more present. Why is that? When lightning strikes on the plains, there is nothing to block or absorb the sound. No tall trees to scatter it, no cliffs to reflect or break it apart. Instead, thunder spreads outward in wide, clean circles, uninterrupted, unhindered. The flat landscape acts like a calm lake for sound. Each thunderclap rolls across it in smooth, low waves, reaching ears miles away with very little loss in strength. The openness also creates a certain clarity. Thunder here arrives with definition. You may hear the initial crack, then the deep belly of the rumble, then a long, fading sigh as it crosses prairie grasses and endless sky. There's a grandeur to it. On the plains, there's nothing to soften thunder. It comes as it is, full and wide and sweeping, yet still, never harsh, just bold and atmospheric. Temperature and humidity help too. Warm summer air thick with moisture, often blankets the plains. And as we know, sound travels slightly faster and farther through warm, humid air. Add to that the inversion layers that sometimes form in the evening: cool air near the ground, warm air above, and thunder can be guided for even greater distances. It's not unusual on the flattest plains to hear a storm you cannot see, one that hasn't yet crested the horizon. The sound gets there first, and when the storm does arrive, it often feels immense. The lightning flickers across wide skies, and thunder follows like a slow-moving train, one long rumble rolling across an ocean of land. You might hear the same thunderclap stretch for many seconds, its voice changing slowly as it spreads outward. The plains become a soundboard, resonant and receptive. And just as forests soften sound and mountains scatter it, the plains preserve it. They let thunder speak without interruption. Now, picture yourself lying in the grass of a vast field. There's no wind tonight, just warm air and tall grass swaying. Lightning dances on a faraway horizon. Then a low murmur begins. It grows into a rolling thunder, steady and full, like a sky-sized cello string being drawn across the heavens. It doesn't bounce, it glides, it surrounds you, and then slowly fades, like a lullaby carried by the land itself. This is thunder's journey across open space. Not rushed, not broken, just free. And as your mind rests beneath this great, calm sky, let the sound carry you like the breeze. Let it roam across your thoughts, the way it roams across the fields, unhurried, unhindered, wide and gentle. And when it fades, know that more stories lie ahead. We'll continue soon. In Chapter 11, welcome back, friend. Tonight, we turn our ears to the quiet mystery of nighttime thunder. You may have noticed it before, that thunder sounds a little different when the sky is dark, softer, somehow deeper, as if the storm itself has hushed its voice for the evening. It's not just in your imagination. There are reasons, subtle, invisible ones, why thunder behaves differently after sunset. Let's begin with temperature. During the day, the sun warms the ground, and in turn, the ground warms the air just above it. This creates vertical movement, rising currents of warm air mixing with cooler layers above. This movement stirs the atmosphere, like a pot of water gently boiling. Sound has to navigate this turbulence, passing through shifting pockets of air at different temperatures and densities. It can scatter, bend unpredictably, or fade more quickly. But at night, the sky settles. Without sunlight, the ground cools. The air closest to the surface cools with it, while the layers higher above remain warmer for a time. This creates what we've met before, a temperature inversion. Cool air resting beneath warm air, like a calm pond beneath a still sky. In this quiet structure, sound is no longer stirred or broken. Instead, it is guided. Thunder can travel farther under these conditions. It's gently cradled by the cooler layer below and the warmer layer above, bouncing between them, amplified, extended. A rumble from many miles away can reach your ears as clearly as if it were much closer. And there's another reason nighttime thunder sounds more vivid. The world is quieter. During the day, our ears are busy. There are cars, people, birds, breezes, machines, movement. Even trees make sound, leaves rustling in the light. But at night, the world hushes, the wind dies down, human activity slows, surfaces cool and become still. All of this allows sound, especially low-frequency sound, to travel without competition. There's less background noise for thunder to rise above, so it feels closer, fuller, and somehow more intimate. Imagine now that you're lying in bed. Outside, the sky has darkened into indigo velvet. There's no wind tonight, just silence. Suddenly, a flash, bright and silver but far away. And then, thunder. Not loud, not sharp, just a long, slow rolling. A sound that seems to stretch across miles of open night, as if it were skimming the surface of the earth, moving gently from horizon to horizon. This is nighttime thunder. It's the same air, the same lightning, the same sky. But the atmosphere has changed its mood. The storm, once full of daytime energy, has grown thoughtful, softer in its voice, wider in its reach. Even indoors, the sound may seem to wrap around you more fully, carried through windows, across rooftops, weaving into your quiet space. And though the storm may be no stronger than one seen by day, its voice becomes a lullaby. As you rest tonight, let the rhythm of the nighttime air carry your thoughts gently forward. Cool, still, slow. The thunder may sound different, but it brings the same calm message. A sky alive with softness. A storm that does not disturb, only passes through. Let yourself pass through it too. And when you're ready, we'll explore another difference in sound. Not in time of day, but in the shape of the light that makes it. Let's drift now into Chapter 12. Hello again, dreamy traveler. Tonight, we're tuning our ears not just to thunder, but to the way it speaks. You've likely noticed that not all thunder sounds the same. Some storms bring long, rumbling rolls that stretch out like low waves. Others come with a single, sharp clap, a sudden crack that fades quickly into silence. These are not just differences in distance. They're shaped by the very thing that creates thunder, lightning. Let's begin with the clap. This sound is usually short, quick, and startling. It feels like the sky has snapped its fingers just above your head. That sharpness is often a sign that the lightning was close, and that it traveled a short, direct path. When lightning strikes near the ground in a relatively straight line, the thunder it creates arrives at your ears almost all at once. The expanding air creates a sudden burst of sound that feels like a single voice, clean, loud, and immediate. Now, let's wander into the sound of the roll. Rolling thunder comes from lightning that takes a longer, more complex journey. Instead of a single vertical strike, the bolt may stretch horizontally across the sky, branching, curling, sometimes extending for several miles. Each segment of that long bolt creates its own sound, but because the lightning covers so much space, the thunder from each part reaches your ears at slightly different times. It's not one voice, but many, layered, blended, softened. This is why you might hear a low rumble that begins softly, swells slowly, and then fades again. It's not a trick. It's the storm taking its time to speak. The shape of the lightning channel also affects the tone. A zigzagging path with sharp angles and twists may create bursts of varying volume. A smooth arc may lead to a more consistent thunder roll, steady and deep. And once again, the air plays its part. Warm, moist air tends to support deeper, fuller rumbles. Cooler, drier air can sharpen the sound into more defined cracks. Terrain matters too. Thunder may echo and overlap, creating complexity. A single bolt can become a chorus of echoes, some sharp, some rolling, depending on the land it crosses. Now, picture yourself lying beneath a summer sky. The clouds are high and slow. You see a flicker of lightning across the horizon, a long silver strand weaving through the clouds. You wait. 1,000. 2,000. And then it arrives. A deep, soft rumble that builds like a low tide, rolling through the fields, touching the trees, and finally fading behind the hills. That was rolling thunder. But another night, closer to the storm, the sky lights up, and almost immediately, a loud crack follows. Clean and quick, a clapping thunder. One isn't better than the other. They are simply different expressions of the same dance between light and air. So, as you listen tonight, see if you can hear the shape of the lightning in the voice of the thunder. Wakor, it's short and close, long and sprawling. Did it clap, or did it roll? Each has a story, and each will fade, gently, into silence. Let that silence carry you now softly, into sleep or stillness. We'll meet the next sound in Chapter 13. Welcome back, friend. Tonight, we journey upward, not into the stars, but into something much closer. The towering, ever-shifting presence of a storm cell. Those tall, billowing clouds we sometimes call thunderheads. They are more than just dramatic sky scenery. They are structured, layered, and alive with quiet complexity. And the way these storm cells are shaped changes the way thunder sounds. Let's begin with the basics. A single thunderstorm is often built around a central storm cell, a self-contained system of rising air, cooling moisture, and electrical energy. Not just a cloud, but a machine of the atmosphere, gently spinning and breathing. Inside, warm air rises quickly, carrying moisture high into the sky. As it lifts, it cools. The moisture condenses into droplets, which form the visible part of the cloud. This rising current is called an updraft, and in strong storms, it can carry air miles into the sky, sometimes reaching heights of 10 or even 12 kilometers. Up that high, near the top of the troposphere, the air is cold and thin, and it's here, near the storm's upper reaches, that lightning often begins. The shape of the storm cell matters deeply. The taller and more complex the storm, the longer the lightning bolt may stretch, horizontally or even through layers of the cloud. A lightning bolt that moves vertically from high in the cloud straight down to the ground creates a more direct, compact sound. This often results in a sharper, more localized thunderclap. But when lightning travels horizontally, arcing across the top of the cloud, the resulting sound may become long and rolling, a soft thunder that seems to stretch out forever. The size of the storm cell also affects how deep or resonant the thunder becomes. Larger clouds contain more moisture, more energy, and more space for echoes. A thunderclap born inside a massive storm may bounce within the cloud itself, layered between regions of different temperature, moisture, and density. This can add depth and fullness to the sound. Picture a bell rung in a large cathedral. The space itself shapes how long the sound lingers. The storm cloud does the same. Even the anvil top, that flat, spreading shape you often see at the top of mature storms, plays a role. It can reflect some of the thunder downward, or spread the energy outward in wide, shallow waves. You may hear a rumble that seems to circle the sky, a storm's way of reaching farther than its core. Now, imagine watching a thunderstorm build in the distance. Its cloud mass climbs higher and higher, growing taller with every passing minute. Lightning dances within the cloud, sometimes hidden, just a pulse behind grey. And then, thunder. Not a single sound, but many layers, arriving together, a rolling wave, shaped by the storm's immense form. The cloud did not simply release the sound, it gave it character. In this way, thunder becomes a reflection of the cloud that made it. So, as you listen tonight, you're not just hearing thunder. You're hearing the shape of the sky itself, a tall, living tower of air and moisture, speaking in slow, sonorous tones. Let that thought settle around you, like the upper layers of the storm settling back into calm. And now, from these towering clouds, let's return to something a little closer, close enough to feel. Let's drift gently into Chapter 14. Hello again, sleepy traveler. Tonight, we're turning toward the kind of thunder that feels close, very close, the kind that arrives right after the lightning. With a sharp, sudden crack, a startling sound that cuts through the stillness like a silver blade. Even when we expect it, this kind of thunder can make the heart jump. But tonight, let's take a softer look at it. Let's understand it, so that it becomes less jarring and more a part of the sky's natural rhythm. Close thunder begins, as always, with lightning. But in this case, the lightning is near, sometimes less than a mile away. And because light travels nearly instantly, you see the flash and hear the thunder almost at once. The sound hasn't had time to spread or soften. It hasn't rippled outward or blended with echoes. It arrives whole, sharp, and direct. This is why it often sounds like a crack or a snap, not rolling, not distant, but immediate. It's easy to think of this sound as something violent, but really, it's just air moving. When lightning travels through the sky, it superheats the air in its path to temperatures nearing 30,000 degrees Celsius. That's 5 times hotter than the surface of the sun, but only for a moment. The air, startled by this sudden heat, expands rapidly, and that expansion creates a shock wave, a pressure wave that moves outward in every direction. That wave is the thunder. The closer you are to the lightning, the more direct that pressure wave is when it reaches your ears. It hasn't bent or bounced. It hasn't faded. It arrives full of clarity. And though the sound can be loud or surprising, it's still just a natural consequence of air adjusting to energy. Think of it as the sky reacting, stretching for a second, and then relaxing again. Sometimes, if the lightning is very close, you may even hear a kind of tearing or sizzling sound just before the crack, a tiny audio trace of the electrical channel forming. And afterward, even sharp thunder fades. The crack becomes a roll, then a hum, then silence again. If you're indoors when this happens, you're safe. Let that comfort settle around you. Close thunder isn't trying to startle you. It's simply the rawest form of the storm's voice, the sound before it travels, before it's softened by hills, trees, or distance. It's the sky speaking plainly, and just as quickly it quiets again. The atmosphere settles, the air calms, and you too can return to stillness. So, if tonight brings a sudden clap, pause. Remember, it's only air. Air moving, air releasing tension, air letting go. Let yourself do the same. Exhale slowly. Feel the silence that follows. You are resting within the rhythm of the sky. One crack, one rumble at a time, and we'll continue, gently, in Chapter 15. Welcome back, dear listener. Tonight, we listen not for the loud, but for the far away. There's something magical about thunder heard from a distance. It no longer cracks or claps. It doesn't startle or demand attention. Instead, it whispers. Low, slow, and endlessly soft, like a memory drifting on the wind. This kind of thunder is often called heat lightning, though that name is a bit misleading. There's no special kind of lightning causing it. What we call heat lightning is simply a distant storm, so far away that you can see the flash, but only barely hear the sound. And when you do hear it, the thunder feels like it's coming from the edge of the world. A low murmur, a velvety sigh in the belly of the sky. Thunder can travel remarkable distances. Under the right conditions, sound waves can journey 10 miles, sometimes more, especially at night. Cool air near the ground with warmer air above forms a gentle sound tunnel, a natural amplifier. The thunder, born from a bolt of lightning perhaps unseen, is guided toward you, softened by miles of motion. The sharpness of the sound is gone by the time it arrives. What's left is a roll so low and smooth, it barely feels like a noise at all. It becomes atmosphere, a presence, a reminder that somewhere, far beyond your view, the sky is alive. Imagine lying in bed on a quiet summer evening. The air is still. A flicker on the horizon catches your eye, pale light behind thick clouds. Then, minutes later, a gentle sound like distant waves brushing a hidden shore. That is the storm speaking softly. This distant thunder brings no urgency, no threat. It simply passes through, as if the clouds were rolling in their sleep. You might not even notice the pattern at first. Flash, pause, rumble. But once you tune in, it becomes a slow conversation between light and sound. Distant thunder moves slowly across the sky, spreading like a blanket over land. It fills valleys, glides over rivers, slips between buildings. The storm that made it may be huge and wild, but by the time its voice reaches you, it has grown tender, and the world around you stays quiet. Birds have roosted, leaves hang still. Even the wind seems to hush itself to make space for the murmur. This kind of thunder feels safe, because it is. The lightning is far, the rain won't reach you. All that's left is a gentle soundtrack of a storm you do not need to face. Let that sound cradle you now, as soft as the brush of fabric, as slow as your own breath. Let it carry you toward rest, a distant lullaby whispered by a sky too far away to wake you. And when it fades, it leaves only silence, a silence that is full of peace. Now, we turn to the next question. Why does that thunder change as it travels? Why does the crisp edge disappear, leaving behind only a hum? Let's drift into the answer in Chapter 16. Welcome back, peaceful soul. Tonight, we explore how thunder changes as it moves, why it begins as a bold sound, sharp and full, and then softens into a distant whisper. Let's begin with how sound works. Every sound you hear is made of waves, pressure ripples moving through air. When lightning strikes, it creates a sudden expansion of hot air, and that expansion sends out a shockwave, a powerful, multi-frequency sound that travels outward in all directions. Close to the lightning, that thunder is rich and complex. It contains high frequencies, the sharp crackling tones, and low frequencies, the deep rolling rumbles. But sound waves don't all travel the same way. As thunder moves across miles of air, the higher-pitched parts begin to fade first. This is due to a natural phenomenon called atmospheric absorption. Higher frequencies are more easily absorbed by the molecules in the air. They lose energy faster, especially in warm, humid conditions. Lower frequencies, on the other hand, are longer and more resilient. They travel farther, they bend around obstacles more easily, they linger, so the thunder that begins with a crack becomes a rumble, and then a hum. As it journeys outward, the further it travels, the simpler it becomes. All that remains is the soft, low part of its voice, the deep tones that slip through forests, across plains, and over hills. This process is also helped by the texture of the landscape. Sound loses energy when it meets trees, buildings, hills, or even the ground itself. Each surface absorbs or scatters some of the wave. So what reaches your ears is only a fraction of the original sound. Add in the curvature of the earth, the thickness of the air, and small breezes, and you begin to understand why thunder sounds so different at a distance. But different doesn't mean less beautiful. In fact, that gentle murmur may be the most poetic part of the storm, a softened echo of something once wild and bright. It reminds us that even powerful things grow quiet with time, that energy always finds balance, that every loud beginning can become a peaceful ending. So now, if you hear thunder from afar, know that you are hearing only the low notes, the calm center of what was once a roar. Let that sound guide you inward. Imagine it passing through valleys, over lakes, through curtains of rain you'll never feel. Let it reach you not with volume, but with rhythm, a breath of sound across a sleeping world. Thunder fades, not because it disappears, but because it travels far enough to become something new. Let yourself do the same tonight. Let your thoughts stretch and soften. Let your body ease into stillness. You are far from the storm, and the only sound that reaches you now is calm. When you're ready, we'll continue gently in Chapter 17. Welcome back, gentle listener. Tonight, we journey into a part of the sky we cannot hear, but that still moves around us, softly, silently, endlessly. We're listening for something called infrasound. It is thunder's secret voice. When a bolt of lightning cuts through the sky and thunder forms in response, it creates not just one kind of sound, but many. Some of these are familiar to our ears: the sharp crack, the deep roll, the gentle murmur, but some of them are too low for us to hear at all. These are infrasound waves, very low frequency vibrations that fall below the range of human hearing. Our ears are finely tuned to frequencies between about 20 and 20,000 hertz, but infrasound waves vibrate at less than 20 hertz. Slow, vast movements of air, more felt than heard. And yet, these waves are very real. They travel long distances, often for hundreds of miles. Their low energy allows them to move through the atmosphere with little resistance. They can bend around mountains, sweep across oceans, slip through the quiet layers of the upper air. Some animals can sense them. Elephants, for example, can communicate using infrasound, sending messages across great distances in rumbles too deep for us to detect. Volcanoes release infrasound. So do avalanches, earthquakes, and distant thunder. Even the aurora, glowing silently in the polar sky, may sometimes create infrasonic pulses. So, when lightning strikes and thunder follows, there may be more to that moment than we can hear. There may be a second story, a sound so low it rides beneath perception, a pulse in the atmosphere, a wave in the sky. Scientists can detect these waves using sensitive instruments called microbarographs. They record the gentle fluctuations in air pressure that infrasound creates, like tracking the breath of the storm itself. And sometimes we feel these waves in subtle ways: a sense of vibration, a pressure in the chest, a sound that isn't quite a sound, but rather a presence. You may have felt it on rare nights when thunder seems to rumble in your bones. When a distant storm makes the windows tremble just slightly. That could be infrasound passing through. It moves slowly, gracefully, quietly beneath the sounds we know. Not every storm produces infrasound, but when the conditions are right, when the lightning is strong and the cloud towers are tall, these sky waves may form and travel through the air unnoticed. Imagine them now, vast circles of motion, stretching invisibly through the dark, touching mountaintops, drifting across plains, passing gently overhead as you sleep. They do not need to be heard to be real. They are the breath beneath the voice, the hum beneath the music. In a way, they remind us that the sky is always speaking, even when it seems silent. Let that thought carry you now. You don't have to hear everything to know it's there. Some sounds are meant to soothe not with noise, but with presence. So, lie still and rest beneath the slow-moving waves of air. You are wrapped in a storm's silent lullaby. And now, as those sky waves drift by overhead, we turn our attention to something softer still, the sound of rain. Let's wander into it in Chapter 18. Welcome back. Tonight, we walk into the rain, not to get wet, but to listen. There's a certain softness in the air when rain begins to fall. The world grows quiet, not because the storm is silent, but because the rain itself is changing the sound around us. You may have noticed this before. A storm builds, thunder rolls, and then, when the rain begins to pour, the sound of the thunder seems to muffle, to fade. It's not your imagination. Rain truly reshapes the soundscape. Each raindrop, though tiny, is a moving surface. And when thousands, millions of these drops fill the air, they become a living filter. Let's look at what happens when thunder travels through heavy rain. As sound waves pass through falling water, some of their energy is absorbed. The droplets act like soft curtains in a hallway, catching, softening, and dispersing the sound. Higher frequencies are the first to go. The sharp edges of thunder, the crisp cracks and snaps. They disappear into the rain, lost in the texture of falling water. What remains is a lower, more distant rumble, the kind of thunder that rolls gently, like a wave behind a curtain. This is why, during heavy rainfall, thunder feels farther away than it really is. The storm could be directly above you, but the sound is subdued, cradled within the rainfall, and the rain itself becomes part of the soundscape, a steady rhythm of droplets, on roofs, windows, leaves, and skin, a whispering hush that covers the world in white noise. Rain creates a kind of acoustic fog, like mist that softens the edges of light. Rain softens the edges of sound. And it's not just the air. Raindrops hitting the ground, dripping from trees, streaming down walls. All of it blends into a background hum, a lullaby composed entirely by water. Now picture it clearly. You're sitting beneath a porch roof or curled beside a window. The rain has begun to fall, steady and sure. The thunder, once sharp and bold, is now gentle, distant, tucked behind layers of sound. You can't hear each clap clearly anymore, but you can feel them. The air trembles faintly. The sky shifts above the soft percussion of falling rain. Even your own breath seems to join in, rising and falling with the rhythm of the drops. This softening of thunder doesn't make it weaker. It makes it closer to the world around you. The storm becomes intimate, not something to watch from afar, but something you're within, cradled in. As the rain continues to fall, let your thoughts fall too, downward, gently, into quiet. Let the thunder roll behind the sound. Let the rain wash away the edges of the day. All you need to do now is listen, not for clarity, but for calm. And when you're ready, we'll continue softly into Chapter 19. Welcome back, dear friend. Tonight, we're looking upward, not to the stars, but to something closer. A soft, grey canopy stretched across the sky, a thick layer of cloud. This cloud cover, often unnoticed, plays a quiet but powerful role in the way sound moves through the air, and especially in how we hear thunder. On days or nights when clouds are high and scattered, thunder tends to roll upward into the vastness, dispersed, scattered, and softened by open air. But when the sky is heavy and clouds form a low ceiling, sound behaves a little differently. It doesn't disappear upward. Instead, it stays close. It bounces. Let's imagine the structure of a cloud layer. Clouds are made of countless tiny water droplets or ice crystals suspended in air. They may seem light and fluffy, but they carry weight, mass, moisture, and depth. And when they gather into a thick, unbroken sheet, they form a sort of acoustic reflector. Thunder, which radiates in all directions from its source, usually moves outward and upward. But when a thick cloud ceiling is just overhead, the upper portion of the sound wave reflects downward, back toward the earth. The result? Thunder sounds louder, fuller, more immediate. It may even seem like the storm is closer than it really is, because instead of vanishing into the sky, the sound has returned to you, amplified. Some call this effect cloud trapping, and it works like the lid on a quiet drum. The sound, contained beneath the clouds, echoes longer and more richly. It lingers, surrounded by moisture and dense air. This is especially noticeable at night. Cool air near the ground and low, thick clouds above create a peaceful chamber where sound can roam and return. A faraway storm might sound like it's directly overhead, each rumble rich and round, with little decay. Imagine now that you're standing beneath that low grey sky. The air is heavy, not in a burdensome way, but in a soft, enveloping way, like a blanket drawn over the world. A flash, and then thunder, not from a distance, but from everywhere at once. It rolls through the streets, between houses, across fields, and then returns. It bounces off the base of the clouds and comes back, softer this time, then again, until all that's left is a hush in the mist. In these moments, even small storms can sound impressive. The acoustic ceiling above transforms their voice, just as a vaulted cathedral can turn a whisper into music. Low cloud cover also dampens high-frequency sounds more quickly, leaving behind the deeper tones. That's why thunder on a cloudy day often sounds low, rich, and rounded. It hums rather than snaps. It surrounds rather than startles. So next time you hear thunder, and the sky above is soft with cloud, know that the sound you hear is a reflection, a gift returned to you by the sky itself. The clouds are not only holding rain, they are also holding sound. Let that thought settle above you now, like a gentle ceiling of mist and motion. And from this quiet sky, let us drift softly outward, to the coast, to where the sea meets the storm. Let's wander gently into chapter 20. Welcome again, wandering soul. Tonight, we stand at the edge of land and listen to how the sea meets the sky. When a storm moves across the ocean, the thunder it brings sounds different, not just because of distance, but because of water. Water, both still and moving, changes how sound behaves. Let's start with the basics. Over land, thunder may bounce off hills, trees, buildings, or even soft ground. But over the open ocean, there are no obstacles, just air and water. This openness gives sound room to stretch. Thunder over the sea often sounds cleaner, sharper, and more defined, especially when it's close. The lack of terrain means the sound doesn't scatter or absorb as quickly. Instead, It glides across the smooth water surface, unbroken, undisturbed. Sound travels more efficiently over flat, reflective surfaces, and the ocean, when calm, acts almost like glass. Thunder seems to skim across it, carried farther than you might expect. Even a distant storm may sound unusually close, but the sea is rarely still. Waves add texture to the surface, ripples and peaks that scatter high-frequency sounds just slightly. The result is a softened version of thunder's voice, still strong but less crisp, a little blurred by motion. Now imagine standing on the shore. To your left, cliffs rise from the beach. To your right, dunes stretch out into the fog, and before you, open water, endless and wide. A storm forms on the horizon. Lightning touches the sea like a quiet brushstroke, and moments later, thunder reaches you. It may sound deep and hollow, as if it's rolling inside a vast chamber, because in some ways it is. The sky above, the water below. These create a corridor, and sound moves through it with grace. If the storm approaches land, the sound begins to change. As thunder reaches cliffs or rocky coastlines, it may echo, bouncing off stone walls, creating a reverberation like footsteps in a cave. Sharp cracks return in softer forms, their edges blurred by spray and wind. The sea has a way of catching sound and sending it back, but not in a rush, in waves. Even the salt air plays a part. More humid air means slightly faster sound travel. And the density of coastal air often enhances the richness of thunder's low tones. You might feel thunder more than hear it, in your chest, in the soles of your feet, a vibration, as if the sea and sky are speaking to one another. Now picture it clearly. You're wrapped in a shawl, standing at the edge of a quiet beach. A storm flickers above the dark ocean. Waves move in rhythm. Thunder rolls like a low tide beneath the wind. And then, silence. Only the hush of waves remains. Thunder over water is a sound of expanse. It reminds us that storms travel. That sound can cross great distances when given space. So, let it travel through you now, wide, slow, and echoing. Let the waves carry your thoughts out to sea, and let them return as whispers. We'll remain here by the shore a little longer, and drift onward to chapter 21. Welcome back, dreamer. Tonight, we lean in, closer, not to the whole of the storm, but to something smaller, a delicate detail hidden inside thunder's deep voice, a crackle tucked inside the rumble. You may have heard it before. A long, rolling thunder murmurs across the sky, but within that roll, a faint flicker of sound, almost like static, a tiny fizz or a stuttering pop. This isn't just imagination, it's real, and it's part of what makes thunder such a layered sound. Let's gently explore what causes it. When lightning forms, it doesn't always flash in one neat line. It branches, splits, stutters. Its path through the air can be jagged and uneven, like a crack in glass or the roots of a tree. Each tiny segment of that lightning bolt causes air to heat up rapidly, creating not just one sound, but many microbursts of sound, all chained together, milliseconds apart. These microbursts create the fine texture within the larger sound. The crackle, sizzle, or static-like fizz you sometimes hear just beneath the thunder's breath. It's the storm speaking in whispers, even as it speaks in roars. This crackle is often most noticeable when the storm is close, when the thunder hasn't yet been softened by distance, when the details are still intact, like the brushstrokes of a painting not yet blurred by time. You may hear it right after the lightning flash. A fizz, a hiss, then the thunder grows and rolls outward. This subtle texture is a clue to what's happening inside the cloud. Lightning is electrical, yes, but it's also chaotic. Each flash is made of countless smaller pulses, called leaders and streamers, tiny, flickering fingers of current that branch out before the main bolt forms. As each one connects, the air responds, sound follows. The crackle is that response, a chorus of miniature thunderclaps, all wrapped into the larger whole. Now imagine lying in bed. The windows are slightly open, and the sky is pulsing with light. A flash, and then thunder begins, long, rolling round. But just before the full voice takes hold, there's a soft crackle, like dry leaves brushing together, or static on an old radio. It lasts only a moment, but it tells you that the lightning was alive with branches, that it danced through the sky before it spoke. Sometimes the crackle is even visible. You might see a sparkle along the lightning's edge, tiny offshoots darting from the main line. What you see is light. What you hear is texture. Thunder is not a single note. It's a song, layered with tones and details, deep rolls, soft echoes, sharp cracks, and gentle sizzles. And within that great, slow breath of the sky is this little voice, the flicker within the roar. So next time thunder speaks, listen a little closer. You may find that the story begins long before the rumble, in a quiet crackle, a shimmer of sound from lightning's many fingers. Let that sound surround you now, not loud, not bright, just textured. Let your breath soften. Let your thoughts scatter like light. And when you're ready, we'll step from sky to street, into the city. Let's drift quietly into chapter 22. Hello again, gentle traveler. Tonight, we find ourselves surrounded not by trees or cliffs or open fields, but by buildings, streets, and stone. The city may not seem like a place for listening to thunder, but it too has its own soundscape, its own voice. When a storm rolls over tall buildings and narrow streets, thunder changes. It becomes a series of echoes, a sound that bounces, bends, and scatters in every direction. Let's explore how this happens. In open land, thunder spreads out in wide circles. It travels across fields, into forests, and over hills with little interference. But in the city, the landscape is vertical. Buildings rise like cliffs. Windows, walls, towers, and rooftops, all of them reflect sound. When thunder moves through a city, it doesn't simply pass by. It ricochets. Each surface acts like a mirror for sound. And unlike natural landscapes that absorb or scatter, glass and concrete tend to bounce sound back almost completely. The result is a kind of echo chamber. A single thunderclap may seem to come from multiple directions. A loud crack overhead, followed by a second voice around the corner, then a low roll weaving between buildings. This layering can make the storm feel larger, as if the sound has grown extra dimensions. And if the buildings are tall and close together, the echoes may repeat several times, softening slightly with each bounce until they dissolve into the hum of the rain. These are urban echoes, a unique kind of thunder only found in cities. Even the shape of streets matters. Long, narrow corridors can act like tunnels, funneling the sound between walls. You may hear thunder coming from one end of a street, then reverberating all the way to the other, and rooftops. They collect the sound and send it downward, into courtyards, stairwells, windows. You might even hear thunder inside, not directly, but as a gentle vibration through walls, or a soft rattle in the window pane. Imagine now that you're sitting near a window in a quiet apartment. The city has grown still. Lights shimmer, A flash paints the buildings in silver for a moment. Then thunder. It begins above you, sharp and close. But then, it moves. It turns a corner. It returns from another direction, as if the sky is walking through the streets. And slowly, it fades, leaving behind the rain. The storm never truly enters the room, but its sound wraps around the city like a shawl. Urban thunder is sculpted by its surroundings, echoed by stone, cradled by architecture, shaped by the very city it passes through. Let that echo hold you now, not jarring, not loud, just present. Let the rhythm of the streets dissolve into your breath. Let the echoes become softness. Even here, in a city of angles and light, the sky still speaks gently, and will follow its voice again. In Chapter 23, welcome back, dreamer. Tonight, we explore something tender, that curious moment when a storm stirs us from slumber, a flicker of light behind closed eyes, a roll of thunder that seems to rise from somewhere deeper than the sky, and suddenly we are awake. Why does this happen? Why does thunder, even when distant, have the power to gently pull us from dreams? It all begins with how we're built. Even while we sleep, our ears listen. The human body has a remarkable system of awareness, one that never fully turns off. Our minds may drift, but part of us always stays just beneath the surface, tuned to the world around us. This is not fear, it's not alarm, it's simply our nature to notice sound, to feel vibration, to respond. And thunder, especially low-frequency thunder, speaks in a tone our bodies understand. You see, we are particularly sensitive to deep, rumbling sounds. Even at low volumes, these frequencies travel farther, and they don't just enter through the ears. They pass through walls, through floors, through skin and bone. We don't just hear thunder, we feel it. It's part of why it wakes us, not because it's loud, but because it's full. It touches the whole room, the whole body. And in sleep, when the world is quiet and still, even a gentle thunderclap can feel like a distant drum calling softly from the horizon. This doesn't mean danger. Thunder is not trying to frighten us. It's simply sound with presence, sound with weight, and our minds, even in dreams, are tuned to notice presence. But here's something comforting. Most of the time, when thunder wakes us, it's not abrupt, it's slow. We drift upward from sleep, unaware at first of what stirred us. Only after we open our eyes do we realize a storm is passing through. And even then, there is a strange comfort in the sound. The room is dim, the air is still, rain taps gently at the window, and thunder, the voice that woke us, now wraps us in its long, slow breath. We listen, we breathe, we return to sleep, because thunder doesn't demand attention. It doesn't shout, it rumbles like a lullaby from far away. And once we hear it, we know we are safe inside. Even the flash of lightning becomes a kind of sky lantern, flickering, then fading. So, if you ever wake to the sound of thunder, let it be a moment of quiet connection, a reminder that you're part of something larger, that even while you sleep, you're held in the rhythms of the world. Let yourself wake gently. Let yourself listen, and then let the sound carry you back downward, into dreams, into warmth, into rest. The storm will move on, and you will sleep again. Now, let's follow that sound. To where it touches the glass, we drift now into Chapter 24. Welcome again, gentle soul. Tonight, we listen for something quieter than thunder itself, the soft rattle of a window pane. Have you ever noticed it? A sudden clap of thunder rolls through the sky, and just after it arrives, your windows shiver ever so slightly. A gentle vibration, barely more than a whisper, and yet it feels close. It feels like the storm has entered the room, but it hasn't. It's just the meeting of sound and glass. Let's explore how it works. When lightning flashes, the thunder that follows carries energy, not just through the air, but as a wave of pressure, moving outward in all directions. If the storm is close, that pressure wave still has most of its strength when it reaches your home. And when it meets a solid surface, like a window pane, it causes a tiny vibration. Glass, though smooth and still, is not immovable. It responds to pressure. It resonates. The lower frequencies in thunder, those deep, rolling tones, are especially good at this. They slip through walls and vibrate within materials, and glass is particularly sensitive. It flexes, just a little, like the surface of a pond touched by a falling leaf. The result is a soft shake, a faint hum, sometimes even a buzz or tremble. It doesn't mean the storm is crashing down around you. It doesn't mean the lightning struck nearby. It simply means that the energy of the sound has found your window and briefly sung through it. Some windows rattle more than others. Older panes, thinner glass, or windows set in loose frames may respond more easily. Sometimes, only one window in a room will react, while the others remain still. The direction of the storm matters too. If thunder arrives from the side where the window faces, you're more likely to hear or feel the shake. But it isn't a sign of danger, just a quiet reminder that sound is not only something we hear, but something that touches. And when thunder touches glass, it reminds us of how closely we're held within the natural world. You are inside, safe, still, warm, but the sky is just outside, breathing and moving. Imagine yourself now, curled near the window. The room is dim. Outside, the storm sighs across rooftops. A flash, a pause, and then the windows shiver like they've caught a chill. But you are still, and the sound moves on. What you felt was just a meeting point, thunder passing by, a sound brushing gently against the edges of your world. No need to brace, no need to wonder. It's only sound, and sound is soft, even when it shakes. So close your eyes, let the windows settle, let the storm drift, and if the glass hums again, know that it's only the sky saying hello as it passes. And soon, we'll follow it farther, into chapter 25. Welcome back, friend. Tonight, we float into something quiet, invisible, but deeply important. Air pressure. It's the gentle weight of the atmosphere pressing down on everything, including you. We don't usually notice it, but air pressure touches everything around us, and even plays a role in how thunder travels. Let's explore this together. When lightning flashes, the thunder that follows moves outward through the air. It's a wave of pressure, a ripple through the atmosphere. The way that ripple moves depends on the air it travels through, and air is never the same in every place or every season. On warm, humid summer nights, you may have noticed that thunder seems to carry farther, longer, fuller. Part of that is due to temperature. Warmer air allows sound to move a little faster. The molecules are more active, more ready to pass along each vibration. But another factor is humidity. When the air holds more moisture, when it's thick with water vapor, it becomes slightly less dense than dry air. That may seem surprising, but water molecules are lighter than the nitrogen and oxygen they replace. This change in composition allows sound, especially low-frequency sounds, like thunder, to travel with less resistance. So, on humid evenings, thunder can roll farther from the storm that made it. It travels across open fields, through neighborhoods, over lakes, all the while carried gently by the dense warmth of summer. And then there's air pressure itself. In high-pressure systems, the atmosphere tends to be more stable. Fewer shifts in wind and temperature mean that sound moves through a calmer, more predictable environment. Low-pressure systems often bring turbulence and rapid changes, scattering or distorting sound. But high-pressure days, especially in summer, create wide domes of stillness, where thunder can stretch and echo, unobstructed. Now, imagine yourself on one of those evenings. The air feels heavy, but not unpleasant, just full. A storm is flickering in the distance, its light weaving behind thick summer clouds. You wait. Then the sound arrives, not in a sharp crack, but in a long, even roll, a voice that travels across miles, wrapped in heat and moisture. It surrounds you slowly, then fades into the air, like steam dissolving into twilight. This is how air pressure, humidity, and temperature all come together to shape the reach of thunder. The storm may be far away, but the sound feels near, carried by the air that holds your breath, your warmth, your stillness. Let that idea settle in your chest, that you are sharing the same air that carries the voice of the sky, a slow-moving sound, in a soft-moving world. And now, from the heavy warmth of summer, we drift into dry places, places where rain does not always fall, but thunder still finds its way. Let's journey gently into chapter 26. Hello again, sleepy soul. Tonight, we listen for thunder that arrives alone, without the company of raindrops. No splashing on windows, no dripping from leaves, just thunder. This is the sound of a dry thunderstorm, a storm where lightning and thunder form high above the ground, but the rain evaporates before it ever reaches us. It happens most often in high desert regions, where the air near the surface is hot and dry. Let's understand how this works. A thunderstorm begins like any other. Warm air rises, moisture condenses, clouds build. Inside those clouds, lightning flashes, and thunder is born. Rain begins to fall from high in the storm, but as it descends through the dry lower atmosphere, it encounters heat and vanishes. This process is called virga, rain that falls but never touches the earth. You may even see it from afar, thin, wispy trails beneath the clouds, fading into nothing. But even though the rain disappears, the thunder remains. It rolls across the desert like a breath made of sound. No water, just wind and sky. And because the air is so dry, thunder behaves differently. It may sound clearer, sharper, with more defined edges. There are fewer trees, fewer buildings, less to absorb or scatter the sound. In these wide, open landscapes, thunder echoes softly across rocky hills and sun-baked earth. It becomes a part of the desert's voice. Now imagine it. You're sitting near a canyon rim. The sky is brushed with late-day color, orange, lavender, fading into night. Far above, a cloud flickers. A lightning bolt arcs silently across the sky. And then, thunder. Dry, round, full. It travels in one long stretch across the plateau, bouncing off stones and cliffs, reaching you without ever having touched a drop of rain. This is thunder without water, a reminder that storms live not just in what they leave behind, but in what they carry through the air. Dry thunderstorms are often short-lived. The cloud builds, flashes, rumbles, then drifts on. But the sound lingers, because in dry air, there's little to muffle the thunder. No dense humidity, no rain curtain, to absorb its voice. Just sound gliding through space, finding its way to you. And though these storms can feel strange, even incomplete, they are part of the natural rhythm, a meeting of heat, height, and motion. So, if you ever hear thunder on a dry wind, don't wait for rain. Simply listen. Let the sound move through you like the wind through desert sage, quiet, crisp, complete in its own way. And when it fades, let your thoughts fade too, into the wide, dry air, into the hush between storms. We'll journey forward from here, into chapter 27. Welcome back, friend. Tonight, we enter a quieter world, a world wrapped in white, where the air is cold, the ground is hushed, and thunder, that bold voice of the storm, appears in the most unexpected way. This is the world of thundersnow, a rare, beautiful meeting of opposites. Lightning in a snowstorm, thunder in the silence of falling snow. Let's take a closer look. Thunder is born when lightning flashes and heats the air, causing it to expand with sudden force. We often associate this with warm, rainy storms, summer skies flashing and rumbling with energy. But every so often, this same process happens inside a snowstorm. Cold, dense clouds build upward, and deep within, conditions become just right for charge to build, for lightning to strike, and for thunder to speak. Yet everything feels different. The snow falls quietly, the light is soft and diffused, and when thunder comes, it's not sharp or crashing, it's muffled, rounded, as if spoken through a heavy woolen blanket. That's because snow absorbs sound. Each flake, so small and soft, catches the edges of the thunder's voice. The echo doesn't stretch far, the roll doesn't last long. Instead, thundersnow brings a quick, hushed clap, gentle and surreal. A sound you might almost miss if you're not listening closely. It may last only a second. One flash, one quiet boom. Then silence again. The world seems to pause, as if the storm itself is holding its breath. Now imagine it. You're watching snow fall outside your window. The world is white, soft, still. Flakes drift past the glass, and the only sound is the gentle tap of snow landing on rooftops. Suddenly, a flash of light. It's not street lamps, it's not headlights, it's lightning, bright against the grey sky. And then, just seconds later, thunder. Rounded and low, not a roar, but a sigh. It rolls through the snow, reaching only as far as the next hill, before being swallowed by silence once more. This is thundersnow. It's rare because it requires the storm to have both instability and moisture, two things more common in warmer months. But sometimes, in late winter or early spring, a strong system pulls in just enough warmth from below, just enough contrast in temperature to trigger the electric dance of lightning and thunder. And when it happens, it feels like magic. The sky glows, the snow continues to fall, and the storm speaks in a language soft enough for sleep. Let the thought of it settle in your mind now. A snowy world, lit briefly by lightning, a sky that rumbles once, then falls silent again. You are warm inside, the windows fog gently, and the storm, though bold, feels peaceful, because in snow even thunder whispers, and we follow that whisper now, into summer. Let's drift gently into chapter 28. Hello again, peaceful traveler. Tonight, we find ourselves under a summer sky where storms rise high, clouds bloom like mountains, and thunder seems to roll forever. Have you ever noticed it? In summer, thunder doesn't just crack and vanish. It lingers. It rolls across the hills, echoes through the trees, and takes its time before fading. Let's explore why, It begins with warm air. During summer, the ground is heated by the sun, and the air above it becomes light, buoyant, full of energy. Warm air can hold more moisture than cold air. This invisible water vapor gives storms extra fuel, helping them grow taller and last longer. When storms build in this warm, moist air, they often become towering cumulonimbus clouds, vast and layered, stretching miles into the sky. This height gives lightning more room to travel. Bolts may stretch vertically, from top to bottom, or horizontally across the wide, flat anvil top of the storm. The longer the lightning bolt, the longer the thunder that follows. Each segment of the lightning path sends out its own sound, and when those sounds reach us at slightly different times, they blend into a drawn-out rumble. That's one reason thunder rolls longer in summer. The bolts themselves are longer, stretching across immense summer skies. But there's more. Warm air is better at carrying sound. The molecules in warm, moist air move more freely, passing the sound along with less resistance. And because summer air is often humid, it helps preserve the deeper tones in thunder. Lower frequencies travel farther and lose less energy. This means that summer thunder not only lasts longer, but feels fuller, more surrounding. Now imagine it. You're lying beneath a wide summer sky. The air is thick with the scent of grass and rain. Cicadas buzz. Clouds tower above the treetops. A flicker of light dances inside a distant cloud. Then, thunder. It begins low. It swells slowly. It rolls, with weight and patience, across the fields and rooftops. You hear it in your chest. You feel it in your feet. And it seems to last forever. That's not just your imagination. The storm is speaking slowly, and the summer air is letting it. Everything in this season is built for long songs, long days, long light, and long, slow rolls of thunder across the sky. Let that sound settle around you now. Let it stretch through your thoughts like warm wind through tall grass. You are resting beneath a generous sky, a sky that doesn't rush its voice. And when the thunder fades, it does so gently. We'll follow that soft roll onward into Chapter 29. Welcome back, gentle soul. Tonight, we wander into something soft, something quiet, something that wraps the world like a whispered breath. Tonight, we walk into fog. You felt it before, that cool, damp stillness that arrives in the early morning or settles gently as night begins to fall. In fog, the world seems quieter. Edges blur, colours fade to grey, and sounds sound different, even thunder. When a storm rumbles through fog, its voice is changed. Not gone, not silenced, but softened, scattered, dreamlike. Let's explore why. Fog is not just low cloud, it's a collection of tiny water droplets suspended in the air, close to the ground. Each droplet is so small that it floats. But together, they form a dense, damp blanket that wraps around landscapes, towns, and sleeping fields. And sound, like everything else, has to move through it. When thunder rolls through fog, it doesn't travel the same way it does in dry, open air. The droplets absorb and scatter the sound, especially the sharper, higher frequencies. Those crackles and pops that thunder sometimes carries, they fade first. What remains is the lower, rounder tones, the long, soft hum of thunder, the part that feels like it comes from inside the sky. So instead of a clear clap or bold boom, thunder through fog arrives like a sigh, a muted wave, a distant drum heard through layers of cloth. It feels close, but also far away. It's an illusion of space, of sound moving through something thick and slow. Now imagine it. You're standing at your window before dawn. Fog all has crept in overnight, filling the streets, brushing the trees, blurring the line between earth and sky. A flash lights up the mist. The clouds above are hidden, but the light is real. And then thunder. Not loud, not clear, but present. A low roll, spread wide by the fog, wrapped in vapor, stretching just far enough to find you. It moves without edges. It blends into the mist. And before you know it, it's gone again. Fog makes thunder feel more like a feeling than a sound. You don't always hear it with your ears alone. You sense it. In your chest, in the floorboards, in the stillness of the room. And because fog often arrives with calm air and cooler temperatures, the thunder doesn't rise and echo. It stays close to the surface, cradled in the quiet. Somewhere above, the storm may be full of energy, but down here, it is wrapped in a hush. Let that hush hold you now. You are inside the softest part of the sky, a place where light is diffused, where sound is subdued, where everything moves a little slower. And when thunder passes through this softness, it becomes something gentle, not a warning, just a reminder that even the loudest voices become quiet when the world is listening in fog. Now, from these misty fields and softened sounds, let's turn our ears toward the longest rumbles of all. Let's wander into chapter 30. Hello again, dear listener. Tonight, we stretch time. We follow thunder not as a single sound, but as a journey. Some thunder doesn't end after a few seconds. It lingers, it rolls and drifts, lasting not 3, not 5, but sometimes 30 seconds or more. These are the longest rumblers. Let's explore how they happen. When lightning forms, it creates a sudden expansion of air. That expansion sends pressure waves outward. We hear it as thunder. If the lightning bolt is short and near, the thunder comes quickly, sharp, strong, and gone. But sometimes, lightning stretches, not just downward, but sideways, horizontally through the sky. Some bolts can span miles, from one cloud to another, or across the wide anvil top of a mature storm. Each part of the bolt causes its own burst of thunder. And as those bursts travel toward you, some arrive right away, while others take longer. The result is a rolling chorus, like many voices singing the same soft note at slightly different times. Each wave of sound reaches your ears in sequence, blending into a long, continuous rumble. And that's not all. These sounds bounce off hills, buildings, valleys, even the cloud base itself. Some sounds take longer paths, reflecting and returning from far-off corners of the sky. You may hear one thunderclap begin deeply, then slowly rise in volume, then fall again, like the swell of an ocean wave. Now imagine this moment. You're lying on your back in a field, or resting by an open window in summer. The clouds above are thick and slow-moving. Lightning dances through them, long arcs drawn across the sky like brushstrokes. A flash, and then thunder. It begins like a whisper, grows, rumbles, pauses, and begins again. Not as separate claps, but one extended sound breathing in the sky. You count the seconds. 1, 2, 3, still rolling. 10, 15, still there. It flows over you like wind, like music without a beginning or an end. These long rumblers are often part of the most powerful storms, but what you hear is not fearsome. It's majestic, a reminder that the sky has depth, and time, and patience. Let yourself sink into that sound now. Let it move slowly around you, unfolding like a wave, like breath, like thought. There's no rush. The thunder will fade when it's ready, and you can follow it into sleep, or simply float beside it, listening, still, and we'll continue this journey in Chapter 31. Welcome back, dear listener. Tonight, we gently follow something shifting, not in light, but in sound. A subtle change in tone, a quiet bending of pitch as the storm moves through the sky. We're listening to the Doppler effect, a soft illusion caused by motion, changing how thunder reaches our ears. Let's begin with the basics. When a sound source moves, the sound waves it produces are stretched or compressed depending on its direction. If it's moving toward you, the waves are gently pushed together, compressed, closer, tighter. The sound becomes a little higher in pitch, a bit sharper. If it's moving away, the waves stretch out. They widen, and the sound becomes lower, deeper, trailing off with distance. This is the Doppler effect, named for the scientist who first described it. You've likely noticed it before. A passing car or train. The pitch of the sound changes as it approaches and fades. A rise, then a fall. And yes, thunder can do this too. When a storm system is moving, the sound of its thunder can subtly shift. A low rumble deepens as the storm drifts away. A sharper, tighter roll arrives when it moves closer. It's not always dramatic. Thunder is already full of tones and textures, so the change can feel more like a mood than a note. But it's there, and it helps us understand where the storm is heading, even with eyes closed. Imagine now that you're resting indoors. Outside, the sky has begun to change. A breeze carries the scent of rain. Clouds press low and wide. The storm is coming closer. Lightning flashes, and the thunder that follows feels clear, rounded, almost sharp. You feel it in your chest, full of energy. Minutes pass, another flash, farther this time. The thunder arrives slower, deeper, trailing behind like a soft curtain being pulled closed. The storm is moving on. You haven't changed your place, but the sound has changed around you. A shift in the pitch, telling you a quiet truth about motion and distance. That's the Doppler effect. It doesn't need to be loud or bold. Even the subtlest change carries meaning. And this isn't limited to thunder. Raindrops too, wind, the soft hum of a plane passing overhead. All of these shift and stretch depending on motion. But thunder makes it feel poetic, because it comes from the clouds themselves, from something vast and untouchable, yet still close enough to change what we hear. Let that thought settle softly now, that the sky's voice doesn't just carry, it bends, it moves with motion, and it tells us where it's been and where it's going. You are safe beneath it, still and steady, while the storm dances overhead. And as it passes, we listen for another quiet surprise, a sound above us, even when the light was far away. Let's rise gently into Chapter 32. Welcome again, peaceful soul. Tonight, we listen to a mystery in the sky. You see lightning far away, maybe out your window, off to the side. But when thunder comes, it doesn't sound like it came from there. It sounds above you, directly overhead, close. How can that be? Let's explore this gentle illusion. When lightning strikes, it creates thunder along its entire path, from beginning to end. And sometimes, lightning doesn't travel in a neat vertical line. Instead, it stretches horizontally, across clouds, across the sky, across miles. These long-reaching bolts, known as anvil crawlers, often form in the flat, spreading tops of storm clouds, where the sky glows pale grey and wide. The lightning may strike far from you. You see it flash on the horizon, a silver arc dancing between clouds. But part of that lightning, somewhere along its path, passed closer, maybe even above you, and the thunder it created. It doesn't all arrive from one point. Sound spreads from every section of the lightning bolt, radiating outward in all directions. So, while your eyes saw the flash to the east, your ears hear the thunder from the center of the bolt, or from the portion nearest you. And if that portion was directly overhead, then that's where the thunder seems to come from. This is one of thunder's quiet tricks. The light tells one story, the sound tells another. And because light travels so much faster than sound, the flash and the rumble feel disconnected, split in time and in space. But they are always connected, always part of the same celestial thread. Now imagine it. You're standing beneath a wide evening sky. The horizon flickers, lightning to the side, quiet and far. You count the seconds. And then thunder. Not behind you, not beside you, but above. A low ceiling of sound, like a sky-sized drumbeat. It catches you by surprise, but it makes perfect sense. Part of that lightning passed near you, even if the bolt's end was far away. This is the gift of long lightning. It reaches far and speaks in many places. Even storms on the edge of your world can speak from above. The clouds carry their voices sideways, like whispers stretched across the ceiling of the sky. So, next time thunder arrives from a different direction than expected, smile softly. You've just heard a wide storm speaking in multiple tones. Let it surround you. Let the light go one way, the sound another. You are in the center, listening to both. And now we follow those voices deeper, into the heart of the storm. We'll continue softly in chapter 33. Welcome back, sleepy traveler. Tonight, we turn inward, not to thoughts or dreams, but to sensation. Have you ever felt thunder, not in your ears, but in your body? Noticed how it seems to arrive in your chest, as if the sky itself is breathing through you? This is no illusion. Some sounds are so low, so powerful, that they move through us, not just to us. These are the bass tones of thunder, the deep, rounded frequencies that rumble low and long, shaking windows, stirring floorboards, and yes, vibrating gently through your chest. Thunder is not one sound, it's a blend, a layered chorus of high snaps, rolling mids, and long, low waves. And it's those long waves, below 100 Hz, that can pass not just around us, but into us. These low-frequency sounds move easily through solid objects, walls, glass, and stone. They're not blocked, they flow, and your body is a part of that landscape. You feel thunder in your chest because your body is made of water, of soft tissue, of pathways that resonate. Sound waves move through your ribs, through your lungs, and rest gently in your bones. It's not a shake, not a jolt, just a pulse, a quiet thrum, like the echo of something old and familiar, something like a heartbeat. Now imagine it. You're lying in bed, rain tapping softly outside. The storm is not yet overhead, but it's near. A flicker, then thunder. It rolls, slow and low, and you feel it more than hear it. A pressure in your chest. A wave beneath your breath. It doesn't hurt. It doesn't frighten. It simply moves through you, as if the earth itself has exhaled, and you are close enough to feel it. Some people describe it as a drumbeat, others as a purring sky, a deep lullaby of air and energy. Whatever you call it, it's part of the natural rhythm between your body and the world. Because sound is not just for hearing, it's for feeling. We are tuned to it, to footsteps, to whispers, to the hum of engines and oceans. And thunder is the oldest hum of all. Let yourself feel it now. Let your breath move with the sound, your chest rising and falling with each low, passing wave. You are not separate from the storm. You are a listener, yes, but also a participant. The thunder does not knock, it resonates, and your body, so quietly alive, answers back. So rest here in the soft vibration. Let it soothe your thoughts. Let it settle your breath. You are part of the sky's slow music, and when it fades, it leaves only calm. Let's follow that feeling now, into the imagination. Let's listen, not with the body, but with the mind's eye. We drift now into Chapter 34. Welcome back, gentle dreamer. Tonight, we close our eyes, not to block out the storm, but to see it differently, because thunder can be seen even with no light at all. Not with the eyes, but with the imagination. Have you ever noticed it? A sound rolls through the sky, and your mind gives it a shape, a texture, a color. Some thunder feels red, deep and warm, some grey, soft and distant. Some a sudden streak of silver or white. It's not unusual. It's not strange. It's something called sound-color association, or, for some, a gentle form of synesthesia, where sounds and tones become visual inside the mind. For others, it's simply emotional. We give color to sound based on how it feels, what it reminds us of, what it brings forward. Thunder, with all its layers and variations, becomes a palette. A sharp crack might flash blue or white, quick, cold, electric. A low rumble might swirl like dark green, like forest fog, a storm settling into the trees, and the long, rolling thunder of midsummer. That might paint your mind in golden amber, warmed by moisture and memory. You don't have to control it, just notice it. Each sound, each tone, leaves an impression, a mark on the canvas behind your closed eyes. Let's try it now. Picture a flicker in the clouds, a flash you don't see, but you know is there. And then, thunder. What do you see? Is it round, like a ripple? Or jagged, like a crack in glass? Is it the color of dusk, of rain, of something unnamed? There are no wrong answers. Your mind is painting the storm as it hears it. Because thunder, though born in light and air, lives in the imagination as much as the sky. It enters the body as vibration and flows into the mind as image. Each person hears it differently, sees it differently, feels it differently, and that is its quiet magic. A single sound, infinite in meaning, a voice from the clouds that becomes color in your thoughts. So rest in that space now. Let your breath rise with the hues. Let your thoughts dissolve into sound and shape. The storm is not just above you. It is within you, a moment of texture, of mood, of quiet creation. And when it passes, it leaves behind not silence, but a softly colored calm. We'll linger here a little longer, then drift onward into Chapter 35. Welcome back, dear listener. Tonight, we lift gently into the upper sky, where clouds don't just float, they layer. Soft veils above soft ceilings, strata stacked one atop the next, suspended in stillness, and in between, a space for thunder to echo. Sometimes, when a storm builds high enough, the sky becomes not just one canvas, but many. Clouds may form in layers, each with a different temperature, a different moisture level, a different shape. And between these layers, there are pockets of space, quiet corridors of air. When thunder is born from a lightning flash, its sound travels outward, down toward the earth, and upward into the layered sky. But sometimes, instead of traveling freely, the thunder becomes trapped, not in a harsh way, but in a lofted soundscape, held between two reflective surfaces, cloud layers that gently bounce the sound back and forth. The result? A longer-lasting, lofted echo. Thunder that seems to hover, refusing to fade right away. Instead of rolling out into the distance, it feels as though it's being passed around in the sky, a quiet game of catch between cloud floors. You may hear it and think, was that one clap, or many? Sometimes the echoes overlap, layering soft bursts upon soft bursts, a murmur behind a murmur. It's thunder, playing in the space above. Now imagine it. You're standing beneath a sky of soft silver. The clouds are low, but above them, more layers are stacked, high and bright and glowing faintly in the dusk. A flash appears within the layers, not sharp, not jagged, just a quiet pulse of light, hidden in the folds of cloud. Then, thunder. It arrives in waves. A first sound, then a softer one, then another, each echo softened by distance and sky. You may not know it, but what you're hearing is thunder being bounced, reflected gently from one cloud to the next. This happens when the air between layers is still, when temperature and moisture create quiet boundaries that hold sound instead of letting it drift away. Like a whisper in a long hallway, the sound stays alive, for seconds longer than it should. It may seem to hang overhead, or move in ways that don't match the light. That's the sky rearranging the paths. It's not confusion, it's choreography, a dance of echoes above you. And because these echoes often lack sharpness, they don't jolt or startle, they cradle. Thunder becomes soft, sleepy, as if the sky is humming to itself. Let that hum hold you now. You are beneath layers of sky, layers of sound, layers of rest. Thunder isn't rushing past tonight. It's staying close, bouncing gently above you, wrapped in clouds. Let it lull you, like waves above the ceiling of your dreams. And now, we climb higher still, to where the earth reaches up into the storm. Let's drift into chapter 36. Welcome again, high above the world. Tonight, we are not on the plains, not in the valley, not beneath the sky, but inside it. We are on a mountain, and when thunder comes here, it sounds different, sharper, closer, brighter. Not because the storm is louder, but because there is less air between you and its voice. Let's understand why. At sea level, the atmosphere is dense. Sound waves must pass through thick, moist air, which slows and softens them, filtering the high tones, stretching the low ones. But as you climb higher, the air becomes thinner. There are fewer molecules to absorb the energy, fewer surfaces to scatter the sound, fewer layers of atmosphere to blur the edges. So, when a storm rumbles above a mountaintop, or even near it, the sound arrives cleaner, sharper, with less delay. Thunder in the mountains feels like it's right there with you, even if the lightning is miles away, and sometimes it is. Storms often hug mountain ranges, their clouds brushing along ridgelines, their lightning streaking through the valleys below. But from your high perch, the storm may feel close, because it is. Even distant lightning can produce thunder that rolls quickly over granite peaks, echoing in tight loops between cliffs and stone faces. Unlike wide plains, where thunder rolls long and low, mountain thunder may bounce quickly, from ridge to ridge, valley to ridge, and back again. It becomes a resonance, a bell rung between peaks. Now imagine it. You're sitting near a high mountain lake. The air is thin, clear, cool. The wind is light, carrying only the scent of pine and stone. Clouds form quickly, as they often do here. The mountain air lifts them, and in moments the sky darkens. A flash, and then thunder. Not distant, It snaps, echoes, reverberates off the walls around you. You feel it in your ribs, in the air itself. It doesn't roll for long, but it is present, as if the storm is speaking directly to you. This is thunder in the high places. It carries less, but reaches more. Even the altitude itself plays a role. Your ears are closer to the cloud base. There is less air between you and the storm's voice. Everything feels nearer, more intimate, but not louder in a harsh way, just immediate. The mountain acts as a sounding board, letting you hear the sky's voice clearly, without the filtering layers of the lower world. Let that thought settle in your breath now. You are not beneath the storm, you are beside it, and its voice is clean and clear, like a drum in open air. No need to run, no need to brace. Just listen, and let the echoes pass through. They will fade, as all sounds do in time, and will follow the next breath of sky. Into Chapter 37. Welcome back, sleepy traveller. Tonight, we follow the sound of thunder into a world both lush and warm, a place where the air is heavy with moisture, and storms rise tall above jungles, coastlines, and coral blue seas. This is thunder in the tropics. Here, the weather has its own rhythm, deep, slow, and abundant. The air carries more water, the heat builds higher, and the sky is often painted with towering clouds that reach deep into the upper atmosphere. When thunderstorms bloom in the tropics, they grow with vertical strength, tall cumulonimbus clouds rising 10, 12, sometimes 18 kilometers high. Within them, lightning forms in powerful, widespread flashes, stretching across vast cloud tops and down into the rain-heavy lower layers. And the thunder that follows, it is unlike thunder anywhere else. It is deep, it is resonant, it is full of moisture and motion, carried through thick tropical air like the strum of a skybound cello. Why does it sound this way? Let's drift into the reasons. First, the humidity. Tropical air holds enormous amounts of water vapor, and as we've learned, moist air carries sound more efficiently than dry air, allowing it to travel farther and preserve the lower frequencies longer. This gives thunder a rounded quality, not sharp or abrupt, but slow and enveloping. You hear it, and you feel it. Next, the height of the storm. Because tropical thunderstorms are taller, lightning often stretches across greater vertical and horizontal distances. That means the thunder is composed of many overlapping bursts of sound, each arriving at slightly different times, blending into a rolling wave that seems to move through the jungle, across the beach, through your chest, and finally, the landscape itself. In tropical regions, the surroundings are often lush, thick forests, winding rivers, broad bays. These surfaces absorb some of the higher-pitched tones, letting the deeper rumble carry through the canopy. Now imagine it. You're in a stilted cottage by the sea. Palm leaves rustle in the warm breeze. The scent of salt and rain drifts through the open windows. In the distance, the clouds have darkened. The sky flashes, not once, but again and again, long, silent pulses of light that seem to float behind the palms. And then, thunder. It doesn't crash, it arrives. A low, spreading sound that wraps around the trees, fills the sky, moves through the air like the tide rolling in. It lasts. You close your eyes, and it's still there, rumbling through your thoughts like a memory too vast to hold. Tropical thunder doesn't need to shout. Its presence is enough. It reminds you that the sky is deep, that the air is alive, that the storm is part of the rhythm of warm places. So breathe with that rhythm now. Let the air be thick, let the thunder be low. Let it roll without end, soft as the night. And as we leave the tropics, we turn toward storms even more powerful, even more rare. Let's listen. To the voice of the supercell, we drift now into chapter 38. Welcome again, gentle listener. Tonight, we step softly into a space where the sky feels enormous, where storms do not merely pass overhead. They build, they rotate, they resonate. We're listening to the rare, unforgettable thunder of a supercell. These are the giants of the storm world, massive, self-sustaining systems that rotate gently within, drawing energy from the earth and releasing it in grand, sweeping gestures. And when they speak, they do so with thunder unlike anything else. Imagine thunder so vast, it rolls for miles. So powerful, it feels like distant artillery, not in violence, but in depth, in sheer presence. Let's understand why. A supercell is a uniquely structured storm. At its core is a mesocyclone, a rotating column of rising air. This rotation helps organize the storm, allowing it to grow taller, wider, and live longer than an ordinary thunderstorm. Within this towering structure, lightning is frequent, stretching from cloud tops to base, and sometimes far outward, reaching into the sky. And with each lightning bolt comes thunder. But not just any thunder. Because of the storm's size, each bolt may travel across miles of cloud, creating a complex soundscape, layered and resonant. And because of the thickness of the air beneath the storm, the sound doesn't rise and vanish. It's held close to the ground, trapped between warm, moist air below and cooler air above, a natural chamber for sound. The result? Thunder that feels slow, booming and heavy. It may begin as a distant growl, then swell into a full-bodied roar that echoes across fields, rolls through valleys, and fades only when it's ready. Sometimes it seems to circle you, reverberating off cloud layers, terrain, even the structure of the storm itself. Now imagine it. You're standing in an open plain. The sky above is layered with steel-grey clouds. In the distance, the horizon flickers. Then, a rumble. Not a clap, not a crack. A boom that begins far away, rolls toward you like a slow-moving wave, and passes overhead. Deep, long, unforgettable. You feel it in your chest, in your knees, in the earth beneath your feet. It isn't frightening, it's awe-inspiring. The voice of a storm too vast to grasp, too patient to rush. This is the thunder of a supercell. Not common, not ordinary, but when it comes, it leaves an imprint, a sound that lingers in memory, long after the clouds have cleared. So rest with that sound now. Let it roll through you, not with fear, but with wonder. You are small beneath it, yes, but safe, still, held, within the breath of something beautiful and rare. We'll follow that breath onward, into chapter 39. Welcome back, our dear listener. Tonight, we listen not just with our ears, but with our minds, our memory, and the quiet space where patterns begin to bloom. Have you ever noticed that some thunder sounds almost like music? A long roll that seems to rise and fall in pitch. A rhythm you could nearly tap out with your fingers. Or a tone that hums softly like a cello in the clouds. This isn't just imagination. It's something real and quietly beautiful. The human brain is naturally wired to find patterns in sound, to organize chaos into rhythm, to hear shape in what seems shapeless, even in something as vast and wild as thunder. Let's explore why this happens. When thunder rolls, it doesn't arrive as one flat sound. It comes as a collection, a blend of vibrations from different parts of the lightning bolt. The bolt may be jagged, branching in many directions. Each segment sends out its own wave of sound. Some arrive quickly, some take longer. As these waves overlap, they create a thunderclap that rises and falls, swells and fades, almost like a symphony played on the air itself. Your brain, always attentive, begins to interpret this. It hears the pulses, the pauses, the changes in pitch. It senses rhythm. It feels tone. And if you're listening closely, or perhaps drifting into sleep, it may sound like music. Not composed, not deliberate, but still musical. Sometimes, thunder seems to echo with a kind of melody. Not notes exactly, but tones that shift from low to high and back again. Sometimes, it beats like a slow drum, with one deep burst followed by two soft rumbles. And sometimes, the silence between rolls feels like a rest in a song, a breath between verses. This phenomenon is even more common in wide, open spaces, where thunder can echo off hills or canyon walls, creating delayed repetitions that feel like rhythmic layering. And in cities, the bouncing of thunder between buildings can sound like chords, soft, blurred harmonies rippling through the streets. Now imagine it. You're lying in a quiet room. Outside, the sky flickers. Then thunder comes, not with a bang, but in a slow, winding roll. It hums low, it lifts, it falls, it pulses once, twice, then pauses, and your mind, without trying, begins to feel it as a kind of song, a lullaby not written but discovered. This is how the human brain turns weather into wonder. How even the most unpredictable sky sounds like something soft, something familiar. You don't need to analyze it. Just listen. Let the music form without instruction. Let it play across your imagination. The sky doesn't need an instrument. It has thunder, it has rhythm, and it has your attention. So rest in that rhythm now. You are part of the music, tucked inside its slow, low notes. And as the final chords roll softly across the dark, let us follow them into the last chapter of this journey. Let's drift into chapter 40. Hello again, gentle dreamer. Tonight, we rest, not just to pause, but to surrender, to release the weight of the day and let the world carry us for a while. And what better way to fall asleep than with the soft, steady comfort of distant thunder? It's a sound that feels far, but never alone. A voice from the horizon, calling without urgency, just presence, just motion. When thunder is distant, its sharpness has faded. What remains is the low roll, the hush behind the hills, the weightless rumble across quiet rooftops. It's a safe sound, a storm that isn't here, a rhythm that doesn't disturb. The flash is hidden, the rain is somewhere else, but the thunder remains, floating across miles of air to find you. And your body knows, you're indoors, you're dry, you're warm beneath blankets and breath. Even in dreams, we understand comfort, the contrast between wildness outside and peace within. Thunder, when distant, becomes part of the bedroom air, like a fan, like a tide, like the hush of wind beyond the walls. It lulls us, not with repetition, but with reassurance. Each roll says, you're safe, you're home, let go. And so we do. We let our thoughts settle with the sound. We breathe slower, we drift deeper. Outside, the thunder may still speak, but we're no longer trying to listen. We're simply held by it. The body softens, the mind releases. Sleep comes quietly, like a cloud, and maybe, just maybe, you'll dream of skies, of clouds that flash but never frighten, of storms that pass like music, never waking you, only singing you deeper. This is the end of our journey together. not the end of the storms or the sound, but of the story we've shared. The chapters have rolled through like thunder, each one a little echo, each one fading gently. And now you rest, not beneath thunder, but within it, safe, still, carried by the hush. Good night, traveller of skies. May sleep hold you gently, and may every rumble remind you the world is still turning, and you are warm inside. Sleep well, and as our journey winds down, I hope this soft exploration of thunder brought you a sense of calm, a gentle wonder for the way the sky speaks, not in words, but in rolling echoes and quiet vibrations. Thunder, like a distant drum, reminds us that the world is always moving, always breathing, but never in a rush. If you've enjoyed this bedtime walk through the atmosphere, feel free to like or subscribe. If, and only if, it feels peaceful to do so. There's no pressure, just presence. You can rest now. There's nothing more you need to think about. Let your breath slow. Let your body grow still. And let the rhythm of thunder echo far away, soft and low, like a lullaby carried on the wind. Even if the storm has passed, its memory hums gently in the air around you. So drift if you wish, or simply lie quietly, listening to the hush between thoughts. Peaceful dreams to you. Calm skies above, and from this voice to your pillow, good night.